So we're going to pick up and we're going to continue talking about the internal business process measures from the Balanced Scorecard. So what we as accountants can look at from the Balanced Scorecard are the financial measures and the internal business process measures. And of the internal business process measures, what we're really talking about is last video we talked about cost of quality. Now we're going to start looking at our measures of time and resource management. And work in process as a percentage of sales is obviously just a financial performance measures, right? Work in process inventory divided by sales tells you how much is in there. So that's not like something we're going to spend a lot of time on, but these obviously, well, except for workstation cleanliness, I don't know who's going to, I don't think any accountant's going to measure that, but they mostly have clean workstations, I've noticed. I know a few who are kind of messy, but anyway, that's not anything to do with this. So moving on, we're going to talk about our time measures and our resource management measures. Balanced scorecard stuff that accountants can help with. All right, so we are going to talk about the manufacturing cycle, right? So again, if you're in a manufacturing organization, that process, how you take your raw materials and turn them into your finished goods inventory, that's huge, right? So the better you're doing at that, the more efficient you are at that, the better you use the machines, the more time you save, the better you're doing, right? So we can measure that stuff, all right? So we're going to look at that. The first thing we're going to look at is the cycle time, right? So this throughput, this manufacturing cycle time, how long does it take us, and what measurements can we get out of that? All right, and so once we can measure it, now we can work to improve it, right? So here's the stages of the delivery cycle, right? So a customer puts in an order, right? Customer, we put in an order or a process, right? We know we're going to make something. So then there's this wait time before we start it. All right, then we start it, right? So here's our start time. So what is going into the throughput time? All right, so the time from when the customer orders it, right, to when it's shipped, that's called the delivery cycle time. All right, that's the delivery cycle. But a good portion of that, well, hopefully not a good portion, but some of it is what's called wait time, right? So there's just a bunch of waste right there when this order is not being made and not being shipped. Until it's shipped, it's not revenue, all right? So we want to get that stuff shipped so we can make it into revenue, right? Okay, so we are very concerned with throughput. Throughput, that's from when the production starts to when it's shipped. Throughput is a component of 4 different kinds of times, okay? It is process time, which is when you're actually using the machines to make the whatever, right? Or the factory or the refinery to turn the oil into gasoline and kerosene and tar, all the different things. It makes the actual process time. Okay, the robots making a car, right? The actual hours the robots and people are working on the car. There's inspection time, so here's some of your quality cost, right? That's the time spent checking it, measuring it, just making sure it's not defective, checking the quality, right? Move time, so that's moving either raw materials or work in process or finished goods to the warehouse, the actual moving, right? And, depending on how you're set up, it can be, something that you need to measure. And then queue time in the queue, in other words, it's waiting to be worked on. right? So when you've moved something from one stage to another and it's just sitting there because this person hasn't finished the last batch, and so this batch is waiting for them. So that batch that's waiting, it got finished with process A, and now it's waiting for process B. So that time it's waiting for the next one. That's called queue time. It's in the queue for process B. It's in the queue for process C, right? So you got these 4 times that make your throughput. So if you look at this and think about this, well, if the quality was all good, right, this wouldn't even be a thing. That's not adding any value to the product. Moving time, that's not adding any value to the product. That's just moving it around because we haven't got it set up so it doesn't move, or it's having to go. And queue time is definitely not adding. That's just sitting. It's had its first part of the process finished. Now it's waiting for the second part. That's it. Or it's waiting to get shipped to the store or whatever, right? So only this process time adds any value to our product, right? This is the only value added time right here. So keep that in mind. So when you're thinking about a throughput time, what you care about is the process time and decreasing all these other times, right? Okay, so let's talk about a performance measure based on this concept. With the idea in our mind that process time is the only value-added time, well, let's divide that by the cycle time and see what we come up with. So value-added time divided by the manufacturing cycle time is equal to cycle efficiency. Okay, and then we can also think about our equipment, right? We can think about a machine that we've paid a lot of money for sometimes. I mean, imagine how many millions of dollars those robots that put together the Teslas are and do things, right? So you're talking mega bucks, a factory and all the machines inside it if it's sitting idle. Can you imagine how many millions of dollars in assets could be sitting around being unused? So how well we're utilizing equipment is something that should probably be measured, right? And when you think about it, right, there's how much we run it, right? So think about a machine, right? So we're going to measure how effective it is. Well, how effective it is a function of how much we run it, right? In other words, I have this machine and it's available to run for a certain amount of time. How much am I running it? Well, that's my utilization rate. How efficient is it when I run this machine, right? Right, so this is like hours. Utilization rate is hours. Efficiency rate is the run rate divided by the ideal run rate. So if I run this machine for an hour, I should get 5 units, right? But when I ran it this week, I really only got 4.5 units. All right, so that's the how efficiently am I running the machine? And quality rate, right? So obviously, as I turn things out, I'm manufacturing units, and these units we would hope would all be perfect, but they're not. So the number that are free to be shipped on divided by the total output gives me a quality rate. So this idea that our overall equipment utility, right, how well we use our equipment is based on the time I run it, right? Am I turning out the number of units per time? And are those units of good quality, right? So those are the 3 measures that go into operating overall equipment effectiveness, right? So let's just put these things to the test. Let's check this out. So we're gonna we're going to look at how well we're doing with our process time. Okay, so let's take a look at this. This quick check here. All right, so here's an example. So we've got wait time 3 days, move time half a day, queue 9.3 days, inspection 0.4 days, process 0.2 days. What's the throughput time, right? So throughput, as you'll recall, is everything except wait time. All right, so throughput is everything except wait time, and process time is your only value added activity. So the throughput time is adding everything except wait time. So 0.4 plus 0.2 is 0.6 plus 0.5. This 0.5 is 1.1. So that's up to 10.49, right? So 10.4. Okay, so throughput time is 10.4. All right, so throughput time is everything excluding wait time. So now we've got our throughput time. Now we can figure out the delivery cycle. So delivery cycle time is everything. So we take our 10.4 and add that wait time. 10.4 plus 3 is now going to be 13.4, right? 13.4. Yes, okay. Now, what is the manufacturing cycle efficiency? So now that I have my manufacturing cycle time and my value added time, I can calculate that out. All right. So the value added time, which was oops, sorry. The value added time, oh, I can just look right here. Is process 0.2. Okay, it's 0.2, and we're going to divide it by 10.4. 0.2 divided by 10.4 is 1.9%. All right, so let's just think about that for a minute. What the heck? We're the throughput on this, whatever it is we're making, Team Norton Corporation, I don't know what they're making, but it takes them 0.2 days to make it. 0.2 days. Their throughput is 10.4. Okay, that means they're spending only 1.9% of their time making this thing. Of their throughput time. That's not even counting the wait time. 1.9% of throughput time is going towards value added activities. The rest of those activities are stuff like inspection, moving, and queue. Check this out. Queue, 9.3 days. You know what queuing was, right? That's it sitting waiting for somebody to do something with it. Okay, so yeah, we need to stomp on that. All right, so let's look at, so maybe there's something wrong with their machine. maybe the queue time is because these machines aren't very efficient. I don't know. But let's look at their machine stuff. All right. So remember, this machine, this efficiency, let's come back and look at that. Overall equipment effectiveness is a function of 3 things: utilization rate, efficiency rate, and quality rate. And here's your how you calculate those. So utilization is how much you run it compared to what's available, right? Utilize it. How much do I utilize it, right? Efficiency rate, if it's supposed to turn out 20 things and it's only turning out 10, my efficiency rate is 0.5, right? And same thing with defect. They should all be defect. So what's my total output? They should be defect free. They should all be, but what's my total divide my defect-free ones by total output, that tells me what percentage of output is defect-free. Then I can just multiply those and come up with an OEE. Okay, so let's look at the numbers. So here we go. So here's what we need for my utilization rate, right? So the machine was available 6,500 minutes this week, but I only ran it 4,550. So I'd take 4,550, divide it by 6,500, and that's going to give me my utilization rate, 40, right? So 4,550 divided by, all right, 4,550 divided by 6,500 is equal to 0.70, right? So if my utilization rate is 70%. I use that machine 70% of what I could have. This is not a good number. This should be 4. I don't know why this is like a copy and paste error on the part of this. So these numbers right here actual, and this is not actual run time, this is actual run rate, right? In other words, when I run this machine, how many things can I make, right? So if I run this machine for 4,550 minutes, 4,550 minutes, I should be making 4 things per minute, right? But I actually made 3.8 things per minute, right? So 3.8 divided by 4 is equal to, that's not bad, 95%. Wow, that's a bad 95, but you get the idea. So I should be able to do 4 per minute. I can do 3.8 per minute this week. So 3.8 divided by 4 is 95%. So my utilization rate is 70%. My efficiency rate is 95%. And so then my quality rate, right? My quality rate, right, is, so this was, so let me just write this so we don't forget. So this is my utilization rate. Oh, you know what? I'm going to type that. Excuse me. This will be much better. Utilization rate equals 70%, right? And if efficiency rate equals 3.8 divided by 4 equals 95%, right? Okay. And again, ideal, this is supposed to be actual run rate, right? Actual run rate, and this is supposed to be 4 units per minute. Okay, actual run rate is 3.8 units per minute. The ideal run rate was 4 units per minute. And when you divide 3.8 by 4, you get 95%. So the very last one, quality rate, right? Defect-free, at least they've done this one right. Total output was 17,290, and of those, 16,000 were defect-free. So 16,000 divided by 17,290, my quality rate is equal to 16,000 divided by 17,290 is equal to 0.925. All right, so I've got my 3 rates. So when I take the utility rate 70% times 9, in other words, I ran it 70% of the time. When I ran it 70% of the time, I got 95% of the units I could have gotten. And of those units I got, 92.5% were okay, right? So if I multiply those 3 by each other, then I'm going to come up with a OEE, overall equipment effectiveness of, hold on, I'm wanting that to be no longer that. I want that to be that. All right, overall equipment effectiveness of 61.5%. So that's, I don't know, I think I'd want my equipment to be a little more effective than 61.5, right? So that could be where some of the issue is coming up with our producing more units, right? In other words, we're not doing too well. I don't think we were doing well. Things were sitting around waiting in the queue for 9.3 days. So I don't know. I don't think that's too good. All right, and so there you go. There's your answer, 6.15. All right, so final bit here, just talking about a balanced scorecard. So we understand there's these 4 categories. We've already talked about those, and they're all interrelated, right? We need to continuously learn and grow and improve, because that's what improves the business process, right? And so we learned a few measurements in the business process, right? We learned our overall equipment efficiency, our manufacturing cycle efficiency, and quality costs. We learned a little bit about those and how to measure those. And those lead to better customer satisfaction, right? Because they're getting things on time, they're getting things that are high quality, so customers are happier. Maybe we've cut costs a little so the price can be lower for the customers, they're happier, they're buying more. And when their customer satisfaction is improved, we're getting our better financial results. So that's the idea behind the balanced scorecard. It's not just financial results, and it's not just process improvement, right? It's overall, right? So here's an example balanced scorecard, right? So for financial, we're looking at contribution margin per car sold and residual income, right? That's what our bottom line, that's what we're looking for. But how do we get there? Well, we use learning and growth. Great, we have better employees sticking around longer, we train them more. Then that becomes better work, right? We have fewer errors, and less time that it takes to install an option, but we have more options available, right? Because employees are better trained, they know how to install things better, it takes them less time to install it, so the process is better. Then they're saying, oh wow, the customers are like, we like this, we're getting these cars when we want them, it doesn't take a long time to get them delivered, they got better options, we like it, we're buying your cars. And then because we've done all of this, we're getting these numbers that we want. Balanced scorecard. So you do kind of start with the financial numbers you want, but you figure out how to get to them through the process, right? Of learning and growth, which makes a better business process, which makes the customer happier, which that gets you to your financial measures. And notice it's not things like return on income that people are going to want to mess with income, want to mess with costs. It's residual income. Anyway, incentive compensation should be linked to this balanced scorecard, right? So that's how managers are getting paid, right? They're going to get bonuses. So if you are a manager in this internal business process area, right, you're concentrating on reducing the number of errors. You're concentrating on the average time to install an option on the car, right? So you're focusing on your thing and getting paid for that, and that presumably is leading into this, right? And which is presumably leading into this. So when you use a balanced scorecard, you have to have something that can be measured, that can be reliable, it makes sense, they're not easily manipulated. Sorry, people will manipulate things. And one last little bit that we want to talk about, the ultimate bottom line is not 100% towards finances, all right? As an organization, this organization is operating within a context of a global world, right? There's other people out there, even though they don't use your product, you still have a social responsibility, right? So your company has to be sustainable. So the Global Reporting Initiative has provided organizations with some ways to measure social and environmental performance. Okay, so even though we've measured everything internally and how it impacts our company financially, we're still part of a larger community. So we want to measure our impact on that community, right? And we want it to be a good impact, right? So the Balanced Scorecard provides a framework for organizing sustainability, right? So within the Balanced Scorecard, you can add things like number of job applicants from underrepresented groups, right? Customers agree your company cares about communities. Water consumption, raw materials, pounds of waste, revenue from eco-conscious products, right? So for each one of the 4 components of the Balanced Scorecard, we're adding some CSR type measurements. And that's important, right? The bottom line doesn't just affect our company. What we're doing at our company is affecting the community outside our company. So it's important to keep corporate social responsibility as part of what is being measured and incentivized. And that brings us to the end of chapter 12 and this week.